Unit 3, Applications of PDE. Problem. A tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially at rest in its equilibrium position. If it is set vibrating, giving point given by or distance given by velocity 3x into L minus x, find the displacement. So this is a problem we are going to concentrate now. So how to do the solution? So we have to identify the problem first. The problem is one-dimensional wave equation. So what is that? Dou square y by dou t square is equal to a square dou square y by dou x square. Okay. For this, what is the solution? The solution is y of x comma t is a cos px plus b sin px c cos pct plus d sin pct. Take it as equation number 1. What are the boundary conditions given in the problem? The following boundary conditions are: number 1, y equal to 0 when x equal to 0, because the endpoints are given in the question for t greater than or equal to 0. Number 2, y equal to 0 when x is equal to L, because length is given in the problem, same condition, t is positive. Third one, again y equal to 0 when time equal to 0, because you know the length lies between 0 and L. Fourth one, the initial velocity is given in the question as 3x L minus x when t equal to 0. 0 less than equal to x less than equal to L. So we are going to eliminate all the constants one by one. Okay. So that we have to apply one boundary condition. So how will you do that? First you apply this boundary condition to this solution. We will get the constant. So apply boundary condition 1 in equation 1. So what is that? Your LHS is 0, a cos 0 plus b sin 0 into c cos pct plus d sin pct. So as you know that cos 0 is 1, sin 0 is 0. So you get 0 equal to a into c cos pct plus d sin pct. So as you know that one should be non-zero, another should be 0. So this is non-zero. So automatically you get a equal to 0. So take it as equation number 2. Substitute 2 in 1. So what do you get? You have to substitute. We have eliminated one constant. So y is equal to b sin px into C cos PCT plus D sin PCT. Take it as equation number 3. So one boundary condition is over. Now you apply boundary condition 2 in equation 3. So we'll be getting any one of the constants. So 0. What is the value for x? It is L into C cos PCT plus D sin PCT. Okay. So already we know this is non-zero. Is it? Already we know it is non-zero. So what is your condition? B sin PL is equal to 0. So we have to get the constants only. But if this is again 0 means once again you are getting 0. So this is non-zero. So what do you get from here? Sin PL equal to 0, which is sin n pi. So don't cancel sin on both sides. We have to find the value for P only. So P equal to n pi. P equal to n pi by n. So put it in the box because we find the value for P, which is my fourth equation. So substitute 4 in 3. Okay. We have to substitute 4 in 3. So what do you get? So we get it as y is equal to B sin n pi x by L into C, put a bracket here, cos n pi ct by L plus D sin n pi ct by L. So look at here, how many constants we are having now? B, C and D. So we have to eliminate the constants one by one. Okay. Take it as equation number. Already we taken the equation as a fourth one. We will take it as 5. Okay. We will take the equation as fifth equation. Now what is the next boundary condition? Boundary condition 3 in equation 5. So what do you get? 0 equal to B sin n pi x by L into C cos 0 because your t is 0 now, okay, plus D sin 0. So what do you get? Cos 0, all of you know that it is 1 and sin 0 also 0. So this is vanishes. Already you know that B also non-zero. So automatically what is your value from here? C equal to 0. This is also non-zero. Okay. So take it as equation number 6. Substitute 6 in 5. So as you see here, you are getting A0, C0. So we are left with B and D. We will see that what is happening next. So you get y is equal to B sin n pi x by L. So C is 0 automatically, is it? So we are getting D sin n pi ct by L. So bring the constants together. So BD sin n pi x by L, n pi ct by L. So bring all the constants together. These two constants you take it as small b. Okay. Sin n pi x by L, sin n pi ct by L. But it is running over n term, is it? So you have to apply the principle of superposition. Okay. We have to apply the principle of superposition means what? You are having so many number of b's, b1, b2, etc. nth term. So we can write up to nth term means automatically it will come as summation. Okay. bn sin n pi x by L sin n pi ct by L. So automatically last equation is fifth equation. So we will take it as 6 here. Okay. So what is the last boundary condition now we have to apply? So the last boundary condition is apply boundary condition 4 in equation 6. So what is the fourth boundary condition? That means we have to differentiate partially with respect to t. So what is dou y by dou t? Because you know the t also 0 here, is it? So summation n equal to 1 to infinity bn sin n pi x by L. We are going to differentiate with respect to t now. Okay. So what is the differentiation of sign here? Cos n pi ct by L into n pi c by L. Because we are differentiating with respect to t, so automatically the constant will come there. Okay. So from here, group the term 1 to infinity bn n pi c by L sin n pi x by L. Take it as equation number 7. So how did you look the last equation? One more LHS condition is there, 3x into L minus x. We will apply the form. So this look like the RHS. The RHS of equation 7 is half range sine series. Okay, half range sine series. So we know that for the half range sine series, we are going to find the value for Bn only. But from here, you are having Bn into n pi c by n, is it? That will carry. So what is the formula? 2 by L 0 to L f of x sin n pi x by L dx. So what is this f of x? That is the function given in the problem, 3x into L minus x. Come on, substitute here, 2 by L 0 to L 3x into L minus x sin n pi x by L dx. So now you know all the Bernoulli condition, how to apply here. Take 3 outside, 6 by L, 0 to L, multiply the term here, Lx minus x square sin n pi x by L dx. So this is like Bernoulli, so u dv. So what is the formula? uv minus u dash v1 plus u double dash v2, etc. So you are going to do Bernoulli now. U is Lx minus x square, dv is sin n pi x by L dx. Okay. So what is u dash? L minus 2x, u double dash is minus 2, u triple dash is 0. Similarly, v is what? What is the integration of sine? Minus cos n pi x by L in, divided by n pi by L, and v1 is minus sine n pi x by L divided by n square pi square by L square. Similarly, v2 is cosine n pi x by L divided by n cube pi cube by L cube. So now you, as you know that uv, u dash v1, u double dash v2. Now substitute all value one by one. So you are having in the LHS n pi c by L, 2 by L. Substitute now. Lx minus x square minus cos n pi x by L divided by n pi by L uv minus u dash minus sin n pi x by L divided by n square pi square by L square plus minus 2 cos n pi x by L divided by n cube pi cube by L cube. So limit is from 0 to L. So as you know that all the sine series will get cancelled because sin n pi will be 0 and sin 0 also 0. So these two terms will be there, but this term also vanishes because it is 0. So we are left with only last term. So you are getting so now if you look at here, you are having 6 by L, this term will be there. Okay. So bring the term to the numerator, it becomes like this. As you know that cos n pi is minus 1 to the n minus 1. You change the sign to the other side. So you get 12 L square will get cancelled. L square by n cube pi cube. 1 minus 1 to the power n. So as you know that we have to give two values. N is odd and n is even. Okay. So n is odd means what is the value you are getting? 24 L square by n cube pi cube, and for n is even you are getting 0. So from here we are getting this value. So actually we have to bring this term to the other side. Okay, bring this term to the other side. So you get Bn is equal to, already you are having 24 L square by N cube pi cube. Already you are having this one. Okay, now you bring this L by N pi c to the other side, where N is odd. Okay, and this one 0, N is even. Okay, so these are the value. So if you multiply, you get it as 24 L cube divided by N power 4 pi power 4 C 0, N is odd and N is even. So we got both the values for Bn. So we will substitute all these answers in your formula definition. So f of x is equal to, f of, not f of x, that is what, y of x comma t, displacement function. So displacement function is, so for the displacement function is y of x comma t is summation n is odd to infinity 24 L cube divided, 24, L cube divided by n power 4 pi power 4 c sin n pi x by n sin n pi ct by n. So if we want to bring the term to the 1 to infinity, means replace n by 2n minus 1. So 2n minus 1, if you replace the term, so you get exactly 2n minus 1 pi x by n, 2n minus 1 pi ct by n. So this is the solution of one-dimensional wave equation.